Hello Math 1680 students. This is a requested video and the request was the general review on regression analysis. Now, I usually prefer to have a specific question so that I can answer the question and while doing so, find out the student's weakness and help the student mend it. I don't really like to have a general review because it'll be repetitive. It has to be repetitive because I have to talk about pretty much everything that I said earlier in lessons. And consequently, a lot of students may feel this is rather a waste of time. Now, how do I make a compromise? Well, here's a compromise. I selected exam problem set so that the students can feel it as a review, a targeted review, and at the same time, other kind of student will feel it as a exam 1 practice. Okay, let's begin. And this is what I'm talking about. The following data table shows the daily high temperatures of Houston, the daily low temperatures of Houston, the daily high temperatures of Dallas, and the daily low temperatures of Dallas for the month of May 2020. And we have all this data from 1st of May to 31st of May for Houston high, Houston low, Dallas high, and Dallas low. And each column has its own mean and standard deviations. Okay, and let's go to the next page. Find a 5-number summary for Dallas high temperature, the 3rd column, and sketch the box whiskers chart. So you can forget about the other columns and then focus on the 31 data for Dallas high. Do the 5-number summary and you can sketch the box whiskers chart. About histogram on Dallas high, again the same deal. Focus upon the 3rd row and produce the frequency table and then produce the histogram. No big deal there. Now, finally, we have a regression problem. The correlation between Houston high and Dallas high is about 0.636 something. I didn't ask you to find out this R value. That'll be really time consuming and you don't have enough time for that during the exam. It's given. And now use this given data set to find the best point estimate of Houston's high temperature if the high temperature of Dallas in the same day was 80 degrees. That's the problem. You're going to find out the estimation of Houston high. You're going to find out precisely. Nothing is precise in statistics. Everything is estimation. Estimate Houston's high if the Dallas high is known. So we know Dallas high, and that's about 80 degrees. And Houston high, we don't, but we want to find out. So we are doing estimation. This is the regression analysis. Okay, how do we handle that? You have to remember this extremely important formula, the regression formula. This is one of 2 methods to handle, and let me talk about my method first. Let's begin with this regression formula. And here, x is given as 80. Dallas high is given as 80. Okay? High temperature of Dallas is given as 80 degrees, and that goes right here. So x is 80. And we want to find out y hat, of course. Now, what are the other characters? Which is which? Let's go back to the problem set. R is given as 0.636 something, correlation coefficient. So this one is 0.6 something, you can plug in. Now this is 80, all right. How about the other 4? That's something you have to figure out. To make the long story short, there you go. X is Dallas high, Y is Houston high, and X bar is Dallas mean, Y bar is Houston mean, and Sx is Dallas standard deviation, Sy is Houston standard deviation, and R is correlation coefficient. The problem gave you, And all these numbers, as a matter of fact, they're all here. They're all here. Houston mean Houston standard deviation. Dallas mean Dallas standard deviation. These four numbers are all there. And the fifth number, correlation coefficient. All these are given in the problem. You don't have to calculate anything. And then what do? Plug all those numbers into this regression formula and run your calculation. There goes your calculation. Dallas High is 80, okay, all right, that's your x. And R is given as 0.636 something. The problem gave you that. How about the other four? You have to make appropriate judgment here. X is Dallas because that's known. We know X, so X is Dallas. And we don't know Houston. So this is estimation. So Y is Houston. So X is Dallas, Y is Houston. And that's what these are. X bar, Y bar. It's bars, so there gotta be averages. But which is which? X is Dallas, Y is Houston. Now how about SX and SY? S is standard deviation, but which is which? X is Dallas, Y is Houston. So known X, unknown Y. Given X, estimate Y. That's how you do regression analysis. Now let's go to this formula a little bit. And let's talk about the theory a little bit so that you can understand this formula better. And that'll really help you memorizing the formula as well. Okay. Please note that this is an equation of line. Not just an equation of a line, it's a slope point equation of a line. What is a slope point equation? What does it look like? In algebra class, we went through slope point equation like this. This is slope, and then running through the point x0, comma y0. Some students may prefer this. Y minus y0 is equal to mx minus x0. Now if I flip this y0 to the other side, we get the first formula. So these two are actually equivalent. This is the slope point equation of the line. Here, slope is this, rsy over sx, and the point is x bar, y bar. Does it make sense? Now, as for slope being rsy over sx, I'm sorry, I cannot tell you why because this is way above 1000 level. So I'll simply have to tell you, and this will turn out to be that way. You'll just have to take it for granted. As for x bar, y bar, I can tell you something. This is what this visualization is all about. We have a scatter plot here. X coordinate is Dallas High, Y coordinate is Houston High. All right, and then we have 31 points. Now, if you select a single point, just one point to explain these 31 points the best, what point will that be? One point to explain these 31. It's got to be the average point. The one number to explain one x value to explain all Dallas temperature, that's the Dallas average, and one y coordinate, one temperature to explain all those Houston high, that's going to be y bar, average. So the line must go through, the line of best fits will have to go through the average point, x bar, y bar, which is somewhere around here where my mouse is. It must go through x bar, y bar. And that's where this x bar, y bar is coming into play. And then slope happens to be r sy over sx. That way, you're not going to forget this. Please remember, this is extremely important formula. Now, a lot of students make some, it's not really a silly mistake, as a matter of fact, make a significant mistake and misplace these characters. Plug in Houston High in place of X bar and so on. And in that case, I can just give you 0 credit. I don't give away these any kind of partial credit for complete lack of understanding. I grade generously as possible for computation mistake or mispunching. But if you misidentify and then use wrong numbers, that means it's not a computation mistake, it's not a silly mistake. It's just a fundamental lack of understanding. It's just a 0 credit. If you know what you're doing, if you know what is X and what is Y, then you can really cash in this problem. This is easy. It's just free 10 points. If you don't know that, then it's going to be 0 credit. And this is a kind of problem that shows up every single time whenever I write first exam. And sometimes 2 problems in a single exam. And a lot of students get 0 out of there because they just put different numbers in different places. And that kind of mistakes can be easily mended if you know what is X and what is Y. So I really emphasize doing appropriate practice. These 2 problems will do a good job there. Now, for the second problem, what is X and what is Y? What's known and what's unknown? What's known? What's known as 65 degrees? It's low temperature of Houston. Houston low, that's X. So here, previously, Dallas high was X and Houston Y was that. So here, X is Houston low. Something is wrong. I cannot do any kind of editing. Okay, X is, I'm running my mouse here. That should be Houston low. And how about Y? I'm running my mouse around. That's Dallas low. If you make this kind of decision correctly, then you cannot miss this problem. We use the same formula, but the key is what is X and what is Y. What is known and what is unknown? Basically, that's the question. In this case, Dallas high is known, Houston high is unknown, and we want to find out. So that's where we have X and Y.